Welcome to Janashakti. I am Professor Dash of Computer Science Engineering Department of Jadavpur University in India. Okay, I am I am teaching generally there the chip design, testing, etc. I know your background that you have worked in this blockchain and so many things. And you are well aware about the development of China. That's very good. Today we like to discuss about the chipware, that is the transfer of the technology from USA to China, where the Trump and the US administration are basically blocking this transfer. So what will happen ultimately? Can China overcome this blockade, or it will succeed? She will succeed by her own technology. So, what is your opinion about it?
Yeah, look, the United States has, for a little bit more than a decade now, embarked on an explicit campaign to strangulate the Chinese economic development model, particularly focused on restricting the export of leading edge technologies to Chinese enterprises, ostensibly in the name of national security, but ultimately it's in the service of a containment strategy. From roughly 2018 onwards, the United States has progressively intensified its sanctioning of Chinese enterprises, particularly those involved in the development and commercialization of communications and information technologies, the most well-known company of which is Huawei, and also prohibiting the sale of leading-edge semiconductors to China from companies around the world. It has also pressured the Dutch to limit the export of critical manufacturing equipment to China as well. So it has been, I think, what you could call a full court press aimed at suppressing and containing China's economic development in areas related to computation, semiconductors, and ultimately artificial intelligence. The result of that combined effort over the course of the last 7 to 8 years has largely been a failure. China has responded, unsurprisingly, to this attempt to contain its economic development by spurring on work in the domestic economy to develop its own capabilities to manufacture, design and manufacture its own microprocessors and semiconductors. Huawei as a company has rebounded through a combination of initiatives. One, it has pivoted to the development and deployment of 5G communication technologies that has ultimately underpinned the rapid automation and application of artificial intelligence in China's industrial sectors. The second thing that Huawei has done is that it has progressed to develop its own semiconductor ecosystem. And it has reached a point now where arguably the quality of its microprocessors is somewhere between 12 and 18 months perhaps behind the leading edge comparable technologies available on the global market. When I've been in China talking to industry and regulators about these issues, particularly in the last 12 months, there is now a very clear sense of quiet confidence that China as a whole has successfully weathered the storm and has developed a capacity that will ensure that regardless of what the Americans do, there is no way that the Americans can forestall significantly China's technology development. So what we've seen in recent times in response to this is, of course, the intensification of the sanctions and the restrictions. Just as one strategy fails, the American administration doubles down and tries to pursue the same strategy just with greater intensity. And I guess Einstein, in a sense, said it well when he described insanity as doing the same thing over and over again in the hope that somehow the next time the result will be different.
That's but that's good that China is also trying its own way. But the problem is that if this Dutch company doesn't supply the main technology, and the US is actually directing this Dutch company not to supply this to this technology of this very low nanometer fabrication, that is about 2 nanometer, 3 nanometer, like this. If China doesn't get it, then ultimately its design chips will not be so fast as that in USA. All right. Then, of course, the China will get the advantage in software. China is very good in software. They are trying to overcome this problem of this hardware by using the software. But ultimately, this hardware matters. If the Dutch company is not allowed to supply this technology, will China will have the success ultimately? What do you think?
Yeah, look, China's made significant advances in lithographic technologies and technologies that supersede the lithographic technology. I would expect that within the next 5 years, China will have a domestic capability that is as good as what's available from the Dutch. And let's not forget that the smallest of the chips that we're talking about are useful in things like smartphones and to some extent Internet of Things devices, but they're actually not the principal technology that's used in the data centers that drive artificial intelligence or in the robotic systems that drive industrial productivity. In fact, most of the semiconductors in those applications are more traditional so-called legacy chips, and China is producing those in spades. So it's important to not forget that, in fact, much of the application cases use legacy technologies rather than the absolute leading edge technologies. The other thing, as you touched on, is that China is using a number of strategies to overcome hardware limitations. Firstly, as you mentioned, China is exploiting software advances that enable more efficient use of a given amount of hardware capability.
Yes.
The second thing that China's doing is that it's using sheer brute force. So it's using, multiple chips, which obviously means at one level it's slightly more expensive on a hardware front, and it does use more energy, but China compensates for that by having incredibly low cost energy. So for a given amount of computational output, the energy input requirements in a Chinese environment is quite comparable. And it's a combination of low energy costs together with more sophisticated and more efficient software. So the end outcome is largely the same. Now, what people should be, I guess, paying greater attention to, of course, is once China does catch up in relation to the hardware itself, it's going to have an advantage across all three domains, which is hardware, software, or algorithms and energy efficiency. And when it reaches that point, it will continue to, I guess, develop its own applications in leaps and bounds. One thing I should also mention is that China has taken a particular view about a lot of the technology stack, and that is that in some critical areas, it is aggressively pursuing open source strategies that essentially bring to the world foundational technologies at zero capital cost, and enables the rest of the world to download and run their own instances of applications and develop new applications on top of these foundational technologies to suit local conditions. And that's quite transformational because it fundamentally changes the business model that has underpinned particularly American big tech, and it also creates or reduces the barriers of entry for global South enterprises and organisations and individuals to move forward with applications development. So they've gotten rid of the moats around foundational technologies, particularly large language models, and have really pushed people down the path of innovating around applications themselves.
But what are these critical areas where China is concentrating?
Look, China has focused ever since 2015 explicitly on developing its capabilities across about 30 core technology areas. And it has reached a point where in about 25 of those it is globally leading, and it is catching up rapidly in the remainder. So in every technology and scientific engineering dimension, China has in the last 10 years really developed in leaps and bounds. Now, that doesn't, of course, happen out of thin air, and it happens in large part because for the previous 30 or 40 years, the Chinese education system has progressively improved the quality and the quantity of educational outcomes and boosted the number of graduates that are coming through the educational pipeline who are capable of working in these fields. The other thing, of course, is that China has in the last few years benefited from a number of globally leading researchers in different technology and scientific fields who have returned to China, in part because of the policies pursued by the previous Biden administrations, the so-called Project China, that targeted Chinese nationals and research scientists and academics in American institutions under suspicion that they were somehow working as spies. So that created a very unattractive environment, and at times risky environment, and an unsafe environment for many of these people who have now gone back to China and set up their own labs and research facilities. So, there's a lot of things that have come together really in the last 10 years or so that has laid the foundations for this technical capability. The last thing I should just add very quickly is that even when China is not necessarily a leading developer of some of these technologies, it's probably fair to say that it is the global leader in the application of many of these technologies in industrial and organizational settings. And in that regard, China is a leading technology society, even if it is not leading in every technology per se.
Oh, no, but that means you are saying that so many scientists and others are coming back to China to build up China, actually. That's fine. But if China doesn't get the exact technology, especially in artificial intelligence, which is coming up very excellently in the next decade, I think, then will not China have a problem like this in this case?
Well, I'd put it the other way. What if the costs of the development and access and use of artificial intelligence in the United States as a result of its proprietary business models makes artificial intelligence inaccessible to most industries and members of civil society? The fact is that it's not only Chinese technical capabilities, which we touched on earlier, exemplified in projects such as DeepSeek, but that's not the only one. But it's the fact that it has been open sourced that is going to be transformational, because what you're starting to see is the rapid downstream development of applications and the adoption of applications on the back of foundational models, and that is penetrating into many spheres of social and economic life already, and doing so at incredibly low cost. So I would often pose the question the other way, which is the American business model a viable and sustainable business model in light of open source based competition?
Uh-huh. So I think you are saying that the business model of China and the business model of USA is entirely different, and that is the advantage of China. That's true. That is what you are saying. That is true. And China is also concentrating on the leading technologies such as the lithography and etc. like this. But you see, this type of technology is always advancing at a very high speed. You are saying that the China will get this new technology within 5 years, but within these 5 years, the technology at USA and the technology at the Dutch company, that will also advance. So will it be possible for China to compete that?
Well, on that theory, China wouldn't be able to catch up, period. And yet it's demonstrated that not only is it catching up, it's surpassed many of the Western technologies over the last, literally in the last 10 years. This is fundamentally why the West is now behaving with such a high degree of displacement anxiety. If the West is so confident that, in fact, its leadership in the world is unassailable, then it wouldn't be responding and behaving the way that it does. Clearly, it understands that the world is changing, and it's not just changing at a technology level, it's changing in a root and branch level. Economic systems are fundamentally transforming. The global distribution of productive capability is changing. That's evidenced by transformations in trade flows. And ultimately, the hollowing out of Western economies and their persistent and deepening financialization is leaving these economies with very little real economic foundations. Now, all of this is coming home to roost. These are part of very long historical cycles. And frankly, I don't think that there's a lot that the West can do to stymie others from making these sorts of developments. And it's not just China that's making these developments. Other countries in the world, India and Russia, two notable ones, are significant leaders in various aspects of technology and scientific endeavour. And the proliferation of know-how and knowledge is such that there's only so much one can achieve by trying to slow others down. America would probably be well advised to focus a little bit more on figuring out its own problems rather than trying to stop others.
As you mentioned, also this India and Russia, along with China. What is your opinion that should India also think about developing AI and others these high-end technologies in their country?
Well, absolutely. But, you'll recall that the founder of OpenAI, Sam Altman, not so long ago told a group of Indian who were attending an event that he was the keynote at that they shouldn't bother competing with OpenAI, that it was so far advanced that there's nothing that India could do. Now, DeepSeek has actually transformed the entire field. And it's done so because by being available as an open source, unlimited, without commercial restrictions, technology foundation, anybody with the foundational knowledge can download and run their own version of the model. Now, what that does is that it enables countries that might not have had their own foundational models to literally leapfrog that process and dive into what I call the downstream value creation elements of applications development in ways that suit local conditions, that respond to local needs, and which take into account local histories and cultures. And that's going to be a far more transformational range of activities for many countries to be working on than necessarily being held back trying to compete at a foundational model level. Ultimately, of course, as countries develop their own ecosystems in this arena, they will make contributions to foundational models that draw from, their own experiences in designing and implementing and operating applications.
But you know that it will be again the same problem. The China and India and Russia will not get the exact high-end technology from USA or the Dutch company, and also India is not having very good lithographic facility. So will not it will not be India it will be far behind of this development.
Yeah, look, India, I think from memory, was certainly not part of the top tier of American friends to receive open access to these technologies under the Biden administration. And, from the point of view of countries that in effect have had their access to these top tier technologies restricted, they will need to think about how they, develop alternative pathways. Now, that's going to involve a combination of things, it would seem to me. One is, of course, looking to collaborate with others who are more advanced to be able to gain access to some know-how, and also making the sort of long-term investments in research and development that is necessary to build domestic capability. These capabilities within societies and economic systems, again, don't materialize overnight. They require an incredible amount of scientific and technical know-how to be able to design things. And then, of course, from there, moving into successful manufacturing is the next challenge. But I think if countries are concerned about questions of long-term national sovereignty, and information infrastructure is a key component of national sovereignty questions, then nation states have no choice but to ensure that they have as many options available to them, that they aren't beholden to any single external power, and that they ultimately develop domestic capabilities as well.
That's fine. We see, and another point is that this AI, the application of AI means actually there is very high-end automation. Actually, automation is involved, and for this automation involved, then India is a poor country. Then will not the many people lose job, and also that will be true in China. And China and India is very vast country. Many in the population wise, I'm saying. See, if many people lose jobs, then there will not be a problem to incorporate this technology or to welcome this technology.
Technology replacing labour, of course, is not new. It has been a feature, particularly of capitalism, for the last 250 years. And in fact, arguably, it was a feature of aspects of feudalism or agrarian economies as well, with the introduction of horse-drawn, plows and those sorts of equipment. So humans have been, to one extent or another, displaced from different roles during the course of recent human history. The question, I guess, always in these situations is the extent to which a society can manage the speed of technology change and labour displacement, whilst at the same time ensuring that the benefits of technology can be harnessed for the majority of people. This is a domestic public policy challenge more than anything else. Of course, the first response of some is to refuse to contemplate the possibility of new technology. And we have many historical experiences of that. The most obvious one, of course, were the Luddites, who sought to smash the spinning jennies so that they wouldn't replace the jobs of people who spun yarn. In the end, of course, we ultimately saw the development of significant textiles industries in Manchester and also in India that, interestingly enough, led to the creation of a whole lot of new kinds of jobs as well. So the historical experience suggests that as jobs are replaced by one kind of technology, new kinds of demands are given rise to in the economic system that will draw on the available labour pool. That's not to say that the available labour pool would automatically, through some magic of the hidden hand or the invisible hand, lead to full employment. And that's the real risk, is that displaced workers will end up being trapped in circumstances that make them unemployable, difficult to employ. And I think it is important that as societies go through episodes of significant technological upheaval, that the right policies are designed and put into place that not only protect people as transitions are being made, but also empower people to take advantage of the changes that are taking place. A free-for-all approach that would see a lot of people lose their jobs and left behind would, of course, be a social disaster. And some societies, I guess, tend to have a higher degree of tolerance for that kind of outcome than others. And but they are the issues that all societies need to deal with as a result of labour replacement, as a result of technology change.
Okay. So definitely this China, India should have taken some alternative way or some methods to absorb those people.
What do you mean? Just run that by me again.
Now, so if this many people lose the jobs, then definitely some alternative arrangements should be done, or just they will be left out.
Look, places like China have shown that their labour markets are incredibly resilient when they've come under stress and under substantial pressure of change. Probably the most recent example of that is the dramatic contraction of the construction industry between 2018 and 2021, which saw, a substantial reduction in the amount of construction work that was taking place. Now, whilst that was all happening, the level of unemployment remained largely unchanged across the country. And at the same time, real wages continue to grow at rates substantially higher than inflation. Now, what that suggests is that workers who were being displaced out of employment in construction were finding their way into the growth sectors. Now, these processes aren't smooth, of course, and some people do struggle more than others in being able to find alternative employment. And from a public policy point of view, ensuring that those people don't fall through the cracks is probably the most urgent priority as societies confront technological change and face the realities of technological transition. And that means reskilling people. It means looking at new business and ownership models that ensure that people who are being displaced don't necessarily lose access to value flow as well. So sometimes one can think of it like this. If technology is going to take your job, then perhaps it's important that you own the technology that's going to replace you. And so the question of the ownership of the critical means of production become central questions to how societies as a whole deal with technological transition.
Okay, that's fine. That's fine. That means that China is taking some policies such that these people are absorbed. Maybe this is a very good thing you told us and you informed us. We should look into this. And that is the end. I think let us end this discussion. It is already, I think, 40 minutes, about 40 minutes are over. So thank you, Professor Powell. I hope that we will again meet and discuss some pertinent issues in the China and USA and in other parts. Thank you very much.
It's been a pleasure to be with you.
Okay, thank you.
Don't forget to like, share, and subscribe to stay updated with the latest incidents. Hit the bell icon to never miss an update. We will see you next time with more news that matters. Stay informed, stay safe.